Okay, we should be up. Now we're back and we're going to recursion. We mentioned recursion briefly in the previous chapter. In this chapter, we'll take a closer look how it's important and how we can work out concise and elegant solutions. Way of defining functions where the function is applied within itself, right? So like the classic example is like something that will call itself. It's a bit hard to explain, but yeah, you can do Fibonacci numbers, so that's a classic example actually, so I can go and fib of 0 is 1, I think. If I recall correctly. One, two, three, four, five, six, 7, 8, 9, 10. Yeah, I think that's correct. And if I commented this out, it would go forever. Right. So we need that. But it'll be very slow. So if I were to run like fib of 20, it would take a reasonable amount of time less. So like 30 would take a while, right? 40 would take a very long time, like maybe 30 seconds or so. Point is, this is not efficient. Like you could easily get this performance far greater in like by not writing it recursively. And I'm curious to see how would you write it so that it's not recursive. Because I know obviously there's a way in imperative languages you just have a number and you increase it, right? You have three numbers, in fact, A, B, and C. And then A, B, and C is the sum of both of them. And then you keep looping through that. But yeah, as you can see, it's going to take a while. And I mean, it's using up quite a bit of memory as well. So, I don't know. We'll see if it finishes. Right, you need an edge condition. So you need to define that. Yeah, you need to define these. So I did it correctly. Yeah, and it's still gonna go for a while. Wow. Maximum. Okay, that's an interesting idea. So I would write a maximum of a list. Takes the list of A, returns the biggest A, but the A needs to be a number, right? So you need to write that. Hey, it's done. There you have it. But yeah, that took a while. That took like over a minute easily. Anyway, the maximum of some list like this is nothing? Or what do you say? Do you just say 0? It's like that's an interesting thing you have to define. Well, I'll do it like this. And then there's an interesting question. What did they do here? You can't, okay, you can't do error. Oh, yeah, of course. So you can't do error. But then the maximum of a list with only one element is obviously that one element, right? And then the maximum of x and xs is So you want to compare x to the maximum of the rest of it. So if x is greater than maximum of excess, it's x. So we'd probably in fact want to define and then let me think about this. To be honest, you could probably just do this. Oops. Uh, and this needs to be ordered, not num. But yeah, I think you could do that. Oops, no more. Okay. Let me GHCI this maximum of 1. Hey, there we go. So yeah, not too bad. I'm sure they didn't use max. I'm sure they wrote it like this. But yeah, that's exactly what I would have written as well. If I couldn't use max. But yeah, it's very and obviously if you just wanted to write max, that would be yeah, obviously it's gonna get mad at you for that, but that's what you do. Or you could have done a guard like this, but eh. Right, so I just did this. Oh, cool, I did this. That's what I did. Huh, nice. That's pretty cool. So that is like word for word what I did. A few more recursive functions. All right, let's do replicate. Takes an integer and returns. Okay, let me try this. Replicate. Takes. Okay. I never imported this. So it would take an integer or something, some kind of num. So it would take that a, and it would also take a b, right? And it would return a list of b, right? A is how many times you repeat it, and then b is what you're repeating. All right, so let me first think about what this is in terms of n, right? So if you want to replicate something 0 times, that's an error, right? Actually, no, it's not. It's just an empty list. Should I do this? Okay. Now, if you want to replicate something 1 time, actually, I feel like you could generalize this. If you want to replicate something n times, and you have this element that you want to replicate, it will be that element, and what you get when you replicate it n-1 times. Right? Am I incorrect for this? This seems right. Let me try it. Replicate. First of all, replicate 0, anything, right? That's empty. Replicate it once. 4 times? Hey. That's nice. That's very nice. I could also just... And if I wanted to check that, I could do... Brilliant. That's cool. That is cool. Cool. Okay, well, they wrote it like this. I mean, I don't... Yeah, this is what I'd write. This is basically what I wrote. And you need ord. Okay. Actually, does ord contain equal, or... So what I'm thinking is, does ord... Right, so it extends equal. So equal is the... Equal is fine here, and in fact less restrictive. Although I don't really know about... No, never mind. Okay, let's do take. Takes a certain number of elements from a list. So take 3 will take... Okay. All right, let's write that up. Take... What will it take? You'll get a list of A. Okay, so you'll have some num of A, right? You'll get an A and a list of B, and it'll give you back a list of B, right? Oops. There we go. N list, right? But if that's 0, first of all, nothing. And again, this has to be equatable, right? Now, if you take one thing, I feel like you have to define taking one thing from a list. No, I don't think you do, actually. If you take n from a list of x and xs, that's x plus taking n-1 from xs. What? What? Excuse me? Huh, what's the error here? Do I need... I already said that this is a number-like type. What's the problem? Oh, oops. There we go. That's a nice, funny way to, Alright, let's load first. Alright. And let's take, first of all, 0, right, from anything. Should be nothing. Taking 1 works. Let's see, what happens when I take, ooh, okay. Right, so it shouldn't, if we try to take anything from an empty list, right, I see. So I think that's what I'd want to do. And now I can do that nicely. Right, nothing should happen. But if I take, say, 7 from an infinite list, cool, so we basically just wrote take. Honestly, where n is less than or equal to 0. Oh. Yeah, I guess that's fair enough. You could do that. Right, but for that, you'd need OR. Right. Although, I mean, personally, you could just hope it's positive, right? Whatever. Still good. And then the rest of it, yep. Reverse is a list. Ooh. Okay, wait, hold on. All right, let's do this. Reverse takes a list of A, spits out a list of A. I don't think you need anything more than that. All right, so first of all, reversing an empty list is that empty list, right? Hmm. Let me think about this. Uh, would it not be this? All right, tell me if I'm wrong, but this looks okay. Hey, nice. That seems right to me, and I don't see how you could do any better than this because colon wouldn't work in this case. There you have it. That's literally like letter for letter what I wrote. Repeat. Okay, oops. This I'm interested in. How do you write repeat? So that takes an element A and it returns a list of A. Okay, all good. Now, if you repeat some X, oh wait, is that not just X and then repeating X? Correct me if I'm wrong. That looks okay. Right, let's see. Hey, there you have it. And I could even use my own methods, so I could take 2 from repeating 4. Could take 854 of them. I mean, it's pretty cool. All right. And there you have it. That's pretty much what we wrote. Yep. just did this as well, same as replicating. And you could even define it like that, right? You could say, well, replicating n in some element is just the same as taking n of repeating that element. Okay, you know what? Let's just use. That seems nice. Ugh. Now, I'm sure there's a way to compose this, but that's a good question. What do I do when? Can I just do this? No. Okay, let me um what? Okay. Take some list of A. Oh, yeah, I don't think that's what I want. Let me get used to. Oh, shoot, zip. All right, let's do zip. Okay. It takes, right, a list of A and a list of B, and it returns a list of tuples of A and B. I think. Let's call it. I feel like we need an edge case here. So first of all, if I have this, that sounds about right to me. And then if you have zip, x and xs, and then y and ys. You have x comma y plus the result of zipping xs and ys. Is that it? I think so. Let me load first. One, two, three, four, four, three, two, one. Wait a sec. If this shouldn't show up. Hey, I think that's it. That's literally what I wrote. That is exactly what I wrote. Okay, well these lines were switched. Oops. Um Looks good. Elem. And sees if it's in that list. Got it. Should be fun. Oops. And I keep doing this. Alright, so it takes an so the A has to be equatable, right? So you need elem to take some kind of equatable A, and you take an A, and you take a list of an A, and I give you back a bool telling you whether that's in that list, right? Now, if you have anything with an empty list, that's false, right? Now, let's, oops. Now, if I have an element of some, like, I don't know, X, right? No. Okay, look, if X is equal to, true, then otherwise, check, okay, that should work. Yeah, pretty much what I wrote. And let's call it, okay, so they called it A. Or you could call it an infix style, I guess, right? But I don't know. I don't see that as natural when it comes to defining the function. Oh, sort. Quick sort. It takes upwards of 10 lines. All right, 1 second. All right, I'm back. Hello. Um, I'm gonna be honest, I don't know too much about quick sort. Uh, I think I have the basic idea. No, but that's merge sort. Merge sort, you take everything and you binary tree it kind of, and you just start swapping the two things and putting them back together and keep swapping. But I don't know quick sort. Okay, first of all, I'm gonna follow along with this one. I probably can't do it myself. So let's do takes. Obviously, A has to be orderable. Um, no, let me type. Oh, it sorts it, right? A sorted list is a list that has all the values smaller than the head of the list in front. Oh. Then comes the head of the list in the middle. Yeah, I guess. Hmm. Oh, I see. I see the idea. Okay. Right. It's not gonna be fast though, but whatever. Yeah, let's do this. Oops. Nope, not interested. They're telling me this is it? I'd rather use filter than whatever this BS is. I'm good, I'll pass. Nice, that is nice. But I mean, I could also define this in like any language. Like I could go and open a Rust and easily write this with just about the same size. That's not the right one. Right, you just have a function quicksort. Yeah, it's a little bit more verbose though. Ooh. You know what? I'll just make this a copy type. That will help me out. Let's just be simple with this, honestly. No reason to be Yeah, I don't think you'd want to collect this actually. I think that's what you'd want. Okay. Right, just I mean, ton of things. Obviously, again, this is clearly not as nice to look at, but it does kind of work if you get the idea. So, well, that didn't work. Oops. What did I do? Right. Of course. Well, this is some brain damage. Hold on. Right. How do I just view? Uh, well, that kind of sucks, doesn't it? Dude, I forgot how you replace. Ugh. Well, anyway, there's your. There we go. Well, this is some serious brain damage, bro. Huh. How is this stack overflowing? This is like the exact same thing I wrote here. What? No, there must just be a simple programming mistake I'm doing. Oh, right, of course. We need to drop the first one. There we go. I feel like there's a better way. You could, I'm pretty sure you can just pattern match this. Can I not do? Uh, okay, I can. Hmm. Oh, stop. What? What exactly is X here? Oh, there you have it. Oops. Mm. Right, from here it's just copy. So There you go. Oof. You could probably just get rid of all that by doing this. Or not. Hmm. Well, there you go either way. Oh. What? It's not even compiling? Wow, that is very strange. I don't know what's going on here. You know, honestly, the best way in Rust is probably just don't do quicksort recursively. Yeah, like that's probably what you'd want. Don't do a quicksort recursively, I guess, is the idea. That makes sense. There's also this idea. I haven't seen that. Yeah, it is easier when you mutate the original array, isn't it? What is this? Uh, and then that delegates to this. And this is the non-recursive version. Yeah, it sounds better than doing. Like sometimes you just can't write the Haskell way in Rust. It just won't work. But hey, why not do some Haskell and get used to that? Oh, you can also do this. There you go. I wonder now, could you do a function to check whether a string contains all the letters in the alphabet? Yeah. You could do it recursively, I guess, but I guess I'd rather not, right? Just I see. Okay. I'm sure there are many better ways to do this, but this is how kind of I do it. They're filtering whether it's an element of the string, right? So filter Oops. Huh. You know what? We just won't do this. There we go. Yeah. I don't know why filter wasn't working though. Oops. This should be true. Yeah. But there's gotta be, I mean, maybe. Eh, I don't know. I don't know how else you do it. Alright, well that's not helping. Oh. Uh oh, I forgot about all, of course. Why does it struggle with this? Am I doing all wrong? Hmm. Well, I guess I need to do this. Okay. So that's what I had to do. But yeah, that's a lot nicer. I don't really need to make this what am I doing? Yes. There we go. But it's, I mean, not going to be extremely fast, but blah, 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 blah. Let me see. Did I hit every letter? No, I did not. It would be nice if it could tell me what letters I didn't hit. And then has all letters could just use that, right? I know how to do that. I was looking this up. Let me think about this. That's not what I want. Is there a complement function that just doesn't? This is what I want. Oh, right, you would want to dot. Is empty type? Check if list. I guess you could do this, right? Null. All right, there. That's what it was. All right. Well, there you go. Okay. Now allow me to reload and figure out which letters it does not have. Okay, man. I really gotta go all the way back here. Oh, wait. I'm a genius. All right. Ah, of course. So if I were to add those, all right. Now, with that, now that should be true. There you go. And if I were to delete even one, it would be false. But if I were to go and add that, there we go. It seems nice and easy. Okay. How could I forget about all, of course? I just didn't realize it was a built-in function. So we've been going for about an hour. Hmm. That is so weird. Well, let's finish this function up then. I mean the article. Yep, there you go. And often the edge case value turns out to be an identity. Identity for multiplication is 1, right? You could probably implement multiplication in terms of addition. Let me do that. Okay. Multiplying something with 0 is 0. Multiplying, okay. Oops. I'm not convinced I even need these, but whatever. Like that. I think it worked. I feel like you could get rid of this though, because what? Does it work with negative numbers? No, it clearly does not. Because that keeps going down. When in reality, it should be getting closer to 0. Well, that's an interesting thing. All right, well, let's work on this tomorrow, or maybe the day after. All right, goodbye.